In this video, we're going to have an intro to functions. So here we have the function, and this whole thing right here is the definition of it. So we're going to have two sets of numbers, x and y, also commonly referred to as the independent variables or the domain, or it could be the y would be the dependent or the range. Those are different ways to think about it. But what we have is two sets of numbers. Then we're going to have a function, which is just a rule or relationship between both of those sets, that when we do that, there can only be one element of x to exactly one, and that's big, exactly one element of y. All right. So let's take a look at some examples. We can see what some of those rules look like and kind of see what that definition really means. So here we have a function f of x, and this would be our rule. Okay, so this rule right here, 3x plus 2, is the function f. That is our rule. So depending on what values they gave us, let's say they gave us -1, 0, and 1, I could then take each of those individually and plug them in. I could take the -1, plug it into x, and see what value I get. I plug it into my rule. So I would have 3 times -1 plus 2 would be -3 plus 2, which would come out to -1. That is going to be my y value that goes with it, right? I can then do that same thing for the 0. 0, 3 times 0 plus 2, which is 0 plus 2, which would be 2. And then I'm going to do the same thing for the 1. I have 3 times 1 plus 2, which is 3 plus 2, which is 5. Okay, so this is the domain. So depending on what domain they give me, it's going to determine my y, and I just take each one of those individually and plug them into the x value each time so that I get the corresponding y value that goes with it. Okay, so that's what a function is. I take numbers, plug them into a rule, and get an output of numbers. All right, you can see how these are independent. All right, it doesn't matter what you plug in here. However, these y values, they depend on what x value you put in. That's why they call them independent and dependent. Okay, let's talk about what it means to be an actual function. So for example, here, let me show you. If I have x squared, right? Let's say I have my table of values. I have x and y. All right, let's say I plug in these two numbers right here. We'll take -3 and 3, for example, right? So I'll plug in -3 right here. I get -3, and you got to put that in parentheses. Okay, so I have -3 times -3, which would give me +9. So that would be a +9 here. All right, now let's do the other 3, the +3. Let's plug that in. I have 3 squared, which would also be +9. Okay, so what we have here is, you look at it, we have, and the x values both are -3 and 3, totally different values, but I have the same exact y value. Okay, so this would be a function. Okay, because if we go back and look at the rule, it says every x can only map to exactly one y, right? So here in this column, I don't have any numbers that are the same. Here I do have the same numbers. Okay, so that -3 goes to 9, the +3 goes to 9. That's okay to be a function. All right, so let me show you what would not be okay to be a function. Let's take, for example, here we have the square root of x. So if I were to plug in, let's say x is a 4. All right, so the square root of 4 could be 2, right? That's what most of you are going to think of, but it could also be -2, because what is -2 times -2? That would be a +4. So what this x value does is it goes to a -2 or a +2. All right, so if you'll look here, I have a 4 that maps to a -2, but the 4 could also map to a +2. So that would make it not a function, since the same x value goes to two different places. That makes it not a function. Okay. Another thing that people like to talk about is they'll look at this x column and they'll say, okay, do I have any values that repeat? If I do have values that repeat, then that would typically indicate that that would not be a function. However, you have to be careful. That's not always the case, right? That's just kind of a lazy way to say what is and isn't a function. The best way to talk about it being a function is I have one element from x to exactly one element of y. That's the best way to explain it. So if you're ever asked to explain why it is or isn't a function, do not use the phrase "because there are no repeating x values" or "because there are repeating x values" to justify whether something is or isn't a function. Use this phrase right here or something similar to it. Only one element of x can map to one element of y. All right, so now let's look at a few more examples here. We have this one here. Here we've got a function, right? We have our rule is this, x squared divided by 2, and we have this whole series of x values. So they're giving us a domain. They're saying, hey, these are your x values. So what are we going to do with every single one of these x values? That's right, we're going to take each one of them and plug them in one at a time and figure out what that will evaluate to, right? And that will determine my y, or my range values. So let's erase this here and let's go ahead and start filling these in, right? So let's take the -4, plug it in right here, right? So I'd have -4 squared over 2. -4 times -4 is 16, divided by 2 is 8. So my first element of y is 8. Then I would go back, do the same thing for -3 squared. That's going to be 9 divided by 2. So that could be, you could write it as the 9 divided by 2 if you wanted to, or it's pretty easy decimal to write. You could say 4.5. Okay, either one of those will work there. And then you would just continue on plugging in each one of these items one at a time. So if there are 1, 2, 3, 4, 5, 6, 7, 8, 9, if there are 9 domain values, there's a chance you could have 9 y values. You're not going to have any more than 9, but you could have less than 9, okay? So if I had more than 9, that meant one of these would map to 2 different numbers, which would make that a non-function. But this will be a function because none of these numbers will map to 2 separate numbers, all right? All right, so in this example, we have S, that's the name of my rule. My rule is negative and then these two absolute value bars of t minus 3. So now the domain they have given me this time is now a -3 and 3 and everything in between. Before, we just had a list of values that listed out all the integers that we could use there and nothing in between. So here we got to do this a little bit differently. So I'm going to make an absolute value table right here. I know I'm going to have the two ends of -3 and 3. Those are my maximum min for my domain. I have negative absolute value of -3 minus 3, which is the absolute value of -6, which is +6. And don't forget, I still have that negative out front, so that would make it in the end a -6. Okay, I'm going to erase that, and then what we can do is we can take this and plot that point. So I'm going to count my 2's on my graph here. So I have -3, so I'm going to go 1, 2, 3, and then -6. So I got 2, 4, 6. So I'm going to plot that point right down there. All right. Now I'm going to go over to the 3, plug the 3 in. Negative absolute value of 3 minus 3, which is absolute value of 0, which is 0. And again, we have the negative that was still out there in the front, but I don't have 0 can't be negative. So that's a 0. So now I'm going to count over 3 and 0. Now, so far what we have is a minimum x value of -6 and a maximum x value of 0. But let's make sure nothing funky is happening in the middle. So let's just choose a 0. I'm going to erase this stuff here. I'm going to plug in the 0. So I got -0 minus 3. So I got absolute value of -3, which is +3. And don't forget, we still have that negative here. So that's -3. So I can plot the point 0, -3. If you'll notice, all those seem to be lining up in line. So if I look at it graphically, and the reason I did it graphically on this one was because of that absolute value part right there. You just got to double check and make sure that nothing weird is happening in your picture. Okay, it's a good way to do it. It's just sketch a quick little graph. So now I know my S values are going to be between -6 and 0. All right. So remember, the function of a rule that you're going to use, your explanation is going to be there is only one x can map to one y. That's your rule. I hope this video helps, and we'll see you in the next one.